Today I'd like to show you some of the features of AXIEM's meshing capability. If you're at all familiar with Microwave Office, you've probably used EMSite in the past. EMSite is a gridded solver, and a structure like this with curved lines would require quite a bit of meshing to get these curved regions here, because that EMSite would require that you stair step with a very fine mesh the curved sections to get as accurately as possible the metal region in there. And one of the nice things about AXIEM is that it's a gridless solver, and because of that we have a meshing capability as shown here that allows us to do a couple things. The first thing we're able to do is in the curved sections, rather than having to do a finely stair-step mesh, we're able to use triangular meshing, thereby significantly reducing the number of unknowns while accurately representing the metal. The second thing we're able to do in AXIEM is in the straight sections, rather than having to have a single rectangular mesh defining the whole structure, we're able to adaptively change the mesh as we get closer to the edges so that we can get a very fine edge mesh. We expect this is where the current and the charge would crowd according to Gauss's law, so we'd like to have a fine mesh on the edges, and we can have a much coarser mesh in the central region here. The combination of these two features allows us to significantly reduce the number of mesh points, thereby reducing the amount of memory and speeding up the solve for the structure as a whole. The other thing that we're able to do with AXIEM is use thick metal. And in this example here, I have two identical structures in terms of the geometry of the problem, but in one case I'm using thin metal, actually perfect electric conductor, so infinitesimally thin, and I'm using a thick metal over here. And we can see in the results that with the thick metal we're getting a whole lot more coupling, because the side walls between the adjacent traces is going to couple energy over in a much more direct way than we would with just the planar coupling that we'd have in the very thin metal layer in the perfect electric conductor. If you have any other questions about AXIEM or about Microwave Office or AWR's products in general, please go to awrcorp.com or contact your AWR account representative.